Autodesk Moldflow Insight has many advanced simulation capabilities, including that of two-shot overmolding. Here we have an assembled 3D mesh showing the first molding in green and the overmolding in yellow. These two will be simulated together to show the influence of temperature and shrinkage and warpage between the two components. First component is made of a polypropylene and the second of an elastomer. We can also set up the process settings for the first component, showing the filling control, packing control, cooling, until we switch to the second component where we can again set the filling control, packing control, and cooling for the entire cycle. And since we are going to simulate the shrinkage and warpage of the components, we set up the warpage to work for both components assembled together. If we take a look at some of the results, fill time can be shown on the first molding and the overmolding. And essentially what we're looking for here is any potential race tracking, hesitation, weld lines, or air entrapments. Legend represents the time it's taking to fill the component, so about 3 seconds in this case. And we can show the same for the overmolding and animate that with respect to time as well. Now, since it is calculating the influence of the two components, we can show what's called a temperature plot. We'll take a cross-section look through the thickness between the two components, and as we animate this, we see the overmolding component coming in influence the temperature of the first molding component, and you can see how that temperature changes over time. Let's go ahead and pause and take a closer look, and we can see all that influence from that second molding coming in influencing the first molding. Since these two components are being molded together, there is the possibility that the second molding component can raise the temperature of the first molding component above its transition temperature, and this is called the remelt area. So the remelt area or remelt zone is where the first molding component actually went above its transition temperature and started to remelt the material. This can be good for adhesion, but possibly bad if it reflows the material. And then lastly, we can show how the two components shrink and warp together. So here we have a deflection plot, and we show that since the materials shrink differently and there is a difference in the profile of the geometry to account for the second molding, we show a significant warpage. This is visually scaled 3 times, and we can animate that to show the deflection, show how it deflects through that scaling. So this in effect can help us determine what we can do to improve the quality of an insert and a two-shot process.